All right. I just started the live stream, so we're on YouTube now. So, yeah, welcome back to workshop number 5, I believe. Um, Today we're going to be finishing up chapter 2. I actually added this day since the last workshop, so we're gonna go over this content, and then we're gonna start chapter 3, which has a lot more, in my opinion, interesting stuff to learn about. So, let's do it. So, chapter 2, day 3, we're not really gonna do a lot of coding. I'm just gonna sort of walk through what this means. But we're gonna talk about borrowing contracts, which is it's very new. In fact, this feature came out, I believe, a week ago. So again, this is very new. Um, so First of all, what does it mean to borrow contracts? Well, let's look at like a why first. So the why is, why would we want to borrow a contract in Cadence? Well, let's say we want to access some function instead of a contract, but we don't import the contract itself. So if we look at this script right here, you'll see that we have a script that's supposed to be returning a UN64, and we're accessing example NFT.total supply. But of course, the error with this script is we're not importing example NFT. So it's not possible to get the total supply, right? This is going to give a huge error saying you can't access total supply because we don't even know what the heck example NFT is. So yeah, right. um Now this is a sort of weird use case because you might ask, well, why not just import the contract? Right? Like if there's an error here and you're saying, well, why don't we just import the contract? You're absolutely right. Is it blurry? Let me go in a little bit. um you could just import the contract and then it would be totally fine. But there are times in Cadence where you can't import the contract. And that's sort of where the conversation of borrowing contracts actually comes into play. So let's say we have two contracts, contract A and contract B, right? And contract B imports contract A, right? So contract B is able to call functions to do a lot of things that exist within contract A. How's this zoom? It's good? Okay. So let's say contract B borrows contract A, right? Now that's all cool. We don't know what this is doing, but it doesn't really matter. Now let's say that I hate this red dot here. It bothers me so much. But let's say that now in contract A, you want to import contract B and you want to, do some stuff on contract B. Well, this isn't possible because there's a circular dependency now. You can't have contracts that import each other because it doesn't work. Um, so yeah, this is bad. So the question is, well, is it even possible for us inside of contract A to do some stuff to call functions or access types inside of contract B? And before a week ago, the answer was no. However, with contract borrowing, you actually can do this. So let's take a look. Um, so before we actually look at the example, let's go over contract interfaces again. Yeah, exactly. So like Ricardo said, this isn't just a Cadence thing, but in the entire software world, circular dependencies is a huge no-no. You should never ever do that. Um, so we know what contract interfaces are. We know the non-fungible token one, right? This is an interface that all NFT contracts must implement. Well, when you attempt to borrow a contract in Cadence, you have to borrow on the interface. Um, that's an important point. So if we look at this example, this is an example of what it means to borrow or to borrow a contract. So we import the contract interface non-fungible token, and then here is our script. So what we're doing is we're first getting an account, let's say 0x01, and then we're going to try to borrow the contract by doing account from the public account dot contracts. So we're accessing the contracts inside of this account dot borrow, and then we put a reference symbol and the contract interface, so non-fungible token. And then you pass in name, which is the name of the contract you're trying to borrow. So essentially what we're saying is, let's go into account 1, or the account with address 1, and try and find a example NFT contract that implements the non-fungible token standard. And if you can't find it, we're going to panic, say contract not found. Otherwise, we can return borrowed contract.total supply, right? Borrowed contract.total supply. And now we're returning our UN64, and we never even had to import example NFT. And the reason we're able to access total supply is because if you go to the standard, if you go to the standard, total supply is inside of non-fungible token interface. Boom. So you could say it's a bypass substitute, but not really. And the reason for not really is because when you think about this, you can only access types and functions that are defined in the interface. For example, if example NFT has like a minter, right? You can't access the minter type because, that doesn't exist in the interface. So you're a lot more restricted. But yeah. So what I want you to do is I want you to think more about, you know, what does this mean if we were to define our own contract interface, right? And, we could start borrowing a lot of contracts that implement that interface. Now, actually, I want to show you. I think this is a pretty cool use case. So Project Toucans, the project that we're currently developing inside of Emerald City, this is a project that allows people to basically deploy their own fungible token contracts. Now, the way that it works is if we actually go to the Cadence stuff, there's one contract called Toucans. Now, Toucans is like the main, factory contract kind of. It's what's handling a lot of the admin like types of Toucans. It's defining what a payout means. It's defining what a funding cycle means. So this is like the main beefy contract, right? And each contract that's being generated, right? For example financial, these are token contracts like flow token, FUSD, that the user will deploy and define their own token. Now you can see that each of these contracts that get deployed imports toucans, right? So it imports toucans from the toucans contract. So what this means is inside the toucans contract, we obviously can't, or we can't import the user's token for two reasons. One, because we can't, or else there would be a circular dependence, and two, because that wouldn't make any sense, because we would have to basically somehow every single time a user creates a new token, we'd have to update this contract and import their contract, which just doesn't make any sense, right? So the only way for us inside of this contract to access some information about the user's contracts is through borrowing the contract using the fungible token interface. So I'm not sure if we're going to actually use that pattern yet, but just to give you a real world example of when you might want to borrow a contract. So there you go. That's it for chapter 2. Any questions about that? And I think I'm going to update this with a little more detail. One thing I want to mention actually, you know what? Do I have this in? I don't. Okay. Well, you know what I actually think would be cool together just to look at right now is if we actually let me bring this down into my computer. Um, One way that we can abstract this code to be kind of cool. Yes, we are recording. Um, One thing that's kind of cool is if we want to take this, we can say, now let's abstract this script a little bit for any account and any contract name, any contract that implements the non-fungible token standard. What we can do is instead of passing in an address, we can or instead of putting a hard-coded address, we can put contract address and contract name, and then simply pass that into the parameters here. And what this script will do is you can pass in any contract address and any contract name, and it will return the total supply for that contract. Pretty cool. So I'll just push that up. Um, so yeah. So again, this is really cool because, instead of having to generate, I'll actually write this here. So instead of having generate a new script with new imports every time you want to get the total supply of an NFT contract, um, you can use the above borrowing method, so you never have to change the Cadence code. All right. All right. Chapter 3. What do we have in store for us? It's clear now. Okay, good. I'm glad that helped clear some stuff up. All right, so chapter 3 is going to be a little less about like actual functioning, like function. That's not true because this one is, but we're going to take a nice little break and talk about organizing information in a script. Um, so we're going to go to the playground and we're going to go to a script here. I love when we're in the playground. Um, let's talk about how to properly return information from scripts. So let's say I have let number be an int, and I want to return number, right? Works. Oh, equals 3. This works, right? Returns 3. Now, let's say that I have a name. It's a string that equals Powell. Powell's typing. How do we return both of these? What if I want to return the int and the string? Is this easy? Or yeah, I create a struct. But try and get creative. Is there another way I can do it without a struct? I want to see. I just want to try and get people thinking for a sec. How else can I turn? It's not a good way. It's a terrible way. But I want to know if people understand it. Right? Yes, needs any struct. How would I do it with any struct? With that type easy. I'm looking for another answer. There's a way I can do it with an array. It's a horrible way to do it, but you can do it. That's not how you do an array in Cadence. That's like C++ or something. Yeah, so what I could do, or TypeScript, yeah, what I could do is return an array of any struct and just return number, name, right? That's possible. Or a dictionary, right? But the main thing that we want to talk about is a struct, right? Um, now, I know that a lot of you know this already, but some people don't, so we're going to talk about it anyway. But in order to return multi-type, sorry, things like this, we usually want to define our own struct. So you can actually define a struct inside your Cadence code called data. I've done it several times. Listen, BC, you're a noob. I mean, it is what it is. So you have a data struct, and what you can have in here is a number that's an int, and you can also have a name that's a string, and then inside the init function, what I sometimes like to do is just say I like to use the underscore space syntax, int, and then um, what you can do is say self.number equals number, self.name equals name, and then up here you can say return data and pass in number and name. And the reason we don't have to use the argument labels is because we did the underscore space syntax, and then we're returning data. So this is a much more structured way of returning information inside of a script. Let's execute this. And on the playground, it's not going to display well, but when you do this on test center mainnet in the real world, it'll be much better when it's returning stuff. Um, oh yeah, this is like the beta playground, right? Yeah. I should probably be using this one, but I'm still on the old one. Actually, you know what? If we want to, just because for the sake of just teaching and somewhat trying, let's just go to the other one. Yeah, let's just do this one. Why not? Cool. I put this down. Okay. Now, obviously with something like this, not very helpful, but it will get very helpful when we want to return a lot of complex information, like when we're reading from the float contract. So, when we want to return the total supply of floats and a reference to one of the float NFTs, you can make a struct called data. You can pass in float.total supply for the total supply, and for the float reference, maybe we're trying to access a certain float ID inside someone's account. So we borrow their float collection, we borrow the float, and then we pass in that reference right here, and we return a nice little data. And as things get much more complex, let's actually take a look at some of the project toucan scripts. Let's look at financial get project. You can see I definitely use it here. Um, And I think actually the reason that I use it here is because sometimes on testnet and mainnet, it will complain if you try and return a reference. So I actually wanted to return project collection.borrow project public, and this gives you a reference to like a public project. But instead, I had to wrap it inside of an info struct and list out all the variables right here. And also, some of the variables were only accessible by calling functions, so it also made sense to just use a struct for this. But this is a real world example of structuring info like this. So pretty simple concept, but just wanted to make sure people were aware of that. Any questions on that? Otherwise, we'll keep going. All right. So yeah, now we're gonna get into some. Wait, do I actually talk about stewardship? Oh yeah, I do. Okay. Yeah, so I would say that the next 2 days of content are probably the most confusing. So bear with me while we talk about these things. But chapter 3, day 2, we're gonna be talking about auth accounts in scripts. So very voodoo weird that we're talking about auth accounts in scripts, but believe it or not, you actually can. Let me think about how I want to set this up though. You know what? I think I want to really dive into this example, so I'm gonna need a bit of setup here. Yeah, of course, I always forget that low NFT example has about 17,000 lines of code. Metadata views is so annoying. I love BRTech. I don't necessarily love metadata views, though. I think it's so overcomplicated. Please don't clip any of this. It's gonna kill me, and I love him, so that would be very embarrassing. Um, I mean, the main reason I hate it is just because I have to deal with stuff like this. Uh, Also, look at that. Even in the official flow example, they're linking things wrong. Now you know, yeah? to all the flow ambassadors out there, maybe this is something that you could try and push for to fix. Have some fighting. Stuff like this is linked wrong. And it's like it's bad because when people try and learn about flow NFTs, they're just seeing wrong examples.
Um, yeah, let me. Shouldn't this be an issue though? We should
True.
probably flag this.
True, yeah. I should make an issue.
And Amethyst, yeah, totally agree on adding the standards to the new playground. I think it was discussed various times, so I don't know why it's not part of it. But let me check in with the team, um, both on so the issues are that there's no ready to go standards to just automatically deploy, right? And that the highlighting doesn't work for the standards or what? Jacob just zoned out completely.
Oh,
He's not
oh,
even
oh, sorry.
listening.
I thought you were talking to Amethyst.
Yeah.
Um,
No, I was just saying, could you repeat what the underline is? It's not picking up the right deployed contract.
oh, this one? Also, I hear myself in the echo.
Oh, sorry.
That's okay. Um, yeah, so the issue here is this also should be linked non-fungible token that receiver. It's just that they have like a missing what's it called? Missing contract interface from their link. And also technically this isn't needed to be linked anymore, but I think it's still good to put there. The real problem
Okay.
is
Yeah.
I can't figure out how to get this. But yeah, that's a great point, Andre. I should just make issues. I don't know why I hesitate so much to comment on GitHub just because I get lost so easily, but I should start just
Hmm.
commenting.
Well, let me pull up the playground repo and someone can playground. This might be a good start to put an issue here. It might get rerouted to the Cadence language server, but yeah, if someone can create an issue there, like you, Amethyst, that would be awesome. And Jacob, instead of being
Yes.
lazy and asking other people to fix things.
True, actually. Oh, also Amethyst. I think oh, Andrea, so there's a when I um the one of the teams at Flow made like a GitHub forum slash discussion for like DevX improvements. Do you know where that
Yeah,
is?
true. Yes, let me find it.
The
That
reason I'm asking is because I
well,
actually you know, now you can't make fun of me. I actually did make a issue about adding the con.
I saw that. I
Yeah.
saw that. Yeah, yeah, yeah. Yeah. Okay. Um, Let me find it real quick. I remember you because I remember looking at it and I remember you having already the the first issue there or something.
Yes. Oh, all right. Looks like we're in business.
Nice. So it
Good.
works?
See. Um, nice. Okay. We're in business right now. Oh wait, but how is that even? Okay, yeah, this is fine. Now I'll go to transaction. I should have done the setup before. I'm sorry, everybody. Why isn't this working? Checking if import pro. Uh,
Oh, there's I don't think you need to say maybe or might.
yeah. Yeah. I'm stupid.
That's
That,
better.
that's name. Did I do? I see they're both deployed to 0x01, so it should be yeah. No, okay. Well, I'll give up on this. Taking too much time. But um, let's go back to this. So yeah, Um, so up to this point, we have basically said that auth accounts can only appear in transactions, right? So when we go to this transaction, boom, there's our auth account inside the prepare statement. And what I said was, it's only accessible there. If you want to change things in an account, you can only do it in the prepare statement. Blah 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 blah. But a couple months ago, actually, they added this really cool thing where you can access an auth account in a script. So you know how when you're in a script, you can say like you can say you can pass in an account, which is an address, or I should call this an address actually, and you can say let public account equals, and this is gonna have a public account type equals get account, and then you pass in the address. This is how you get a public account. Well, you can also get the auth account by saying get auth account address. Now, it's not supported in the playground. However, this actually works on testnet and mainnet. Um, so yeah, you can get an auth account. Now you may be wondering, oh, isn't that super dangerous? It's really bad because if I have your auth account, I can withdraw NFTs, I can withdraw your tokens, I can mess with your capabilities. But does anyone know why it actually doesn't matter? And it's a pretty obvious answer. Why is it totally fine that I can access anyone's auth account in a script? Yeah, exactly. There's no mutation. You can't do anything in a script. So even though technically I could, withdraw all your NFTs right here, um, by the time the script is over, it's not gonna. It's everything's gonna reset. So it's not an actual problem at all. So it's totally fine. Um, so what we're gonna be looking at today is, well, why would you then need an auth account inside of a script? So let's take a look. Um, One of them is relinking to discover data. So you're only going to really understand this use case if you worked through most of chapter one. But let's take a look. So um, in this case, let's say that we're trying to access, and you know what? It to make maybe more readable, I'll bring it into here. But ignore the red lines, right? So let's say that we're trying to pass in a user's address, and we want to get an array of all of their, example NFTs, right? And what we're gonna do is we're gonna run the script, and let's just pretend we just ran it, and oh no, we got an error. It said, sorry, non-fungible token collection public was not linked. So we talked about in chapter one how to prevent this problem in the first place, but let's talk about how to deal with it after the fact, right? This was not linked. Uh-oh, that sucks. So how do we read the user's NFT IDs? Well, what we can do is we can use an auth account to relink their data directly in this transaction, or in the script, sorry. So if we look here, um, what we do is we get their auth account, we unlink the collection path, and then we relink their account with all the proper stuff, with non-fungible token, not collection public, with receiver. Now, in this case, because we only need collection public, we don't even really need to care about this. So all we care about is that we properly link it with example NFT and then non-fungible token, not collection public. That way, now when we go to read their NFTs, it actually works because even though the user doesn't have it linked, we just relinked it for them in the script, and then we're able to read their IDs. Now, of course, once the script is over, their account's still going to go back to being terrible, right? It's going to be wrongly linked, but this is one way that you can, fix that type of thing. Now, the reason I mention this is because in chapter one we talked about, well, what if we don't have the auth account? Maybe we can try and borrow it like this, right? Maybe we can try and borrow it with receiver, but at that point you're playing a guessing game, right? You're guessing over and over again. How was this linked? Is it linked in this wrong way that I can read it like this? All that stuff. The cool thing with auth accounts is that you no longer have to guess, because you can just relink it and know for a fact that because this is now linked, this will work. So pretty awesome, right? Now, another thing that's really useful with auth accounts is we can discover data that's not linked to the public, right? That's super cool. So a lot of the times when you go to or sometimes when you look at like an NFT contract, um, they have a specific function that you're not allowed to. Actually, let me see if the float. No, but sometimes there's certain functions that the public can't call, right? That gives you certain access to some of the NFT's data. So let's say that in this example, in example NFT, there's a function called borrow example NFT that gives you a reference to the whole NFT, not just the non-fungible token reference. So when we go up here, let's say that the NFT has, I don't know, a name, string, has a fave number, int, all these different things, right? Now, when we use the borrow NFT function, we're only going to get the ID. But when we call this function, we're going to get the name, the favorite number, the ID, everything. Now, let's say that borrow example NFT is not public. For some reason, it's not linked publicly. What we can do is we can still call into the user's collection using the auth account and then be able to call this function and get all the information that we need. And we can do that by, if we look here, you can actually, with the auth account, no longer have to use capabilities. So in this case, you have to get the account, you have to get the capability, you have to borrow on it publicly. With the auth account, you can literally just borrow from storage and then call those functions that give you access to all that data. And those are two out of the three main use cases, but the third use case is what we're going to cover in the next day. So yeah, there's another tool to help you navigate scripts. Everyone good on that? Right. People are all good. Sweet. Thumbs up. So let's go to day 3, and we're going to talk about storage iteration. Um, yeah. Let me just see again. Okay. I think I'm actually going to pause there, because I want to set up a whole example for you guys for storage iteration because it's actually really cool. Um, so you know what? Instead of doing day 3, we're gonna skip day 3, and we're gonna go to day 4, and then next time we're gonna spend a ton of time on day 3. So let's just go skip to day 4. Um, Now this is something that isn't really a complicated example or a complicated topic at all. It's just something that I see sometimes, and if you're an experienced software developer, you already know this type of thing that I'm going to be talking about. It's pretty trivial. But again, I've seen this mistake a little bit, so I'm going to cover it today. So, um, getter functions. We know that getter functions is something that reads data. So this occurs instead of a script when we want to read some data from our contract. So if we have a contract like this, right, we can have a function that gets a profile, right? So um, you have a function that looks into the profiles dictionary, and oh, what's the link to this here? Link to the content. Um, so yeah, so what you can do is You can have a get profile function that reads into the profiles dictionary and returns a reference to one of the profiles based on the ID. So we have two options. We can either write it like this or we can write it like this. One of them is panic aborting if it doesn't exist, and one of them is returning an optional type. Now, the point of this chapter, or this day, although very small, is to say that this is more likely the correct way to do it. Um, so let's talk about why. Um, yeah, so this is what I call prioritizing nil over panic. It's usually better when you're doing getter functions to always prioritize the nil because you don't want to necessarily panic abort, or developers that are reading into your contract don't necessarily want to abort if it doesn't exist, right? They want the option to say, okay, if this thing is nil, then we want to do something else. But if it's not nil, then we can do this thing, right? So it gives developers the option to choose. Um, so I don't know exactly what I was getting at here, but oh yeah, another thing. So sometimes when people are reading or running scripts, they're calling into your contract, right? And what's going to happen is if they pass through an ID and the profile panic aborts, right? It's returning a actual reference and not an optional, and it's aborting, then this script is going to return an error. So the people that are, calling this data on the front end or whatever client is calling into this code is going to have to handle errors if, if the data doesn't exist. Whereas in this case, it's actually a lot nicer because this returns an optional, and so it'll just the script will be a success, but it'll return null. And so the client that's calling into this code will be allowed to handle the null case, not have to deal with annoying errors. So main point of this day is to say if you ever have a getter function, I would always prioritize returning an optional type rather than panic aborting to give developers the option to choose, how they want to deal with, it not existing or anything like that. Yeah. Also, Andrea linked the discussions. Oh yeah, so this is great. So this is like a discussions board for all DevX related stuff, and you can see Amethyst. This was the discussion I was talking about that you had mentioned. And good news, it says we are aware of this need and have plans to implement a similar feature soon. Woo! Heck yeah! Okay, but when?
Are you just gonna keep going until someone laughs?
Yeah.
Haha, funny.
All right, the bootcamp's over.
Do you mind zooming in a little bit on the GitHub one?
Sure, yeah.
Because I think dark mode for some reason gets compressed harder than light mode. Yeah, perfect. That's enough. Thank
Sure,
you.
sure, yeah.
Great. Yeah, this is really great,
Yeah,
as Busy says.
yeah.
Yep.
All right. Yeah. So that's all I have to say for today. Next time we'll come back and we'll talk about chapter 3 or day 3, and then we'll move on to chapter 4, which has some pretty cool stuff in it. What is this? Oh yeah, proving identity and time and structuring transactions correctly and miscellaneous. And
Now, be honest.
what?
With the miscellaneous, did you have to look up how it was written?
Yeah, I did. I actually did. I literally had to look up like this. Yeah, I did that, and then it like came up, and I was like, "Let's go," and I copied it.
I think everyone has to do that when they write that word.
Yeah. Oh yeah, look at chapter 5 also. This is gonna be pretty fun. It's an assessment. So it's a the whole
Ooh.
entire thing is a complete test. It's a long test actually. It's
I mean,
an exam. Yeah, it's an exam. SAT, yeah.
it would be cool to make this exam on chain, wouldn't it, Jacob?
It would be pretty cool. It would be really cool, yeah. Challenges. All right, anyways, that's all I have for today. So I'll see you all on Friday. I'm happy that we're having one on Friday. The vibes are compatible on Friday. Go enjoy the Doodles hype on Twitter. Oh, BC has a question. What's the question, BC?
Yeah. Yeah. So, Andrea, how long did you know about doodles?
Uh, Not too long.
A
Why?
week? A month?
Uh, I don't know exactly, but a little bit.
Probably 3 or 4
Maybe,
years.
yeah.
Yeah.
Honestly, when they announced Doodles 2, I I was hoping and thought that they were going to come to Flow because Flow is just the best place to come.